Because here's the thing. Thank you for joining me. So right now we are having a very dangerous situation unfolding at the Taal Caldera. We are having 17 volcanic earthquakes, as I said, including one volcanic tremor event. Okay, one volcanic tremor event. Okay, that means there's so it's only one, so that's good. Duration of 40 minutes, 45 minutes, and 16 low-frequency volcanic earthquakes, and low-level background tremor that has persisted since April 8th, 2021. High levels of volcanic sulfur dioxide or SO2 gas emissions and steam-rich plumes that rose as much as 2,500 meters that drifted southwest, southeast, and northwest. That was generated from the Taal main crater. Sulfur dioxide emissions averaged 22,628 tons per day. Based on ground deformation parameters from electronic tilt, continuous GPS, and in-center monitoring, Taal volcano has begun deflating in April 2021, while the Taal region continues to undergo very slow uplift since 2020. Extension means uplift. So what does that mean? This means, from reading this here, that the magma is moving elsewhere. You see this very high emission of sulfur. There is a huge amount of magma that is currently going into the chamber or somewhere in the caldera. There is a huge amount of magma that is rising upward and is causing the volcano to basically depressurize. The fact that it's releasing so much sulfur is a good sign. That means that there is probably an eruption of some sort that is taking place below the lake level. Well, not explosive, or it means that there's a lot of magma going into the chamber that is causing all these emissions. It's normal for Taal to have emissions averaging a few thousand tons a day. For example, let's go to Campi Flegrei. Okay, so let's go here. I just want to show you something. Press releases and weekly bulletins. Let's go to the statement for June 29th. This is talking about carbon emissions, CO2. As you can see, fluctuations, but this is, I don't know if this is tons. But as you can see, there's wide fluctuations, but this is carbon and this is not in tons. And also the lake temperature has been steady at 71.8 degrees Celsius. However, Taal did have an eruption, a ferretomagmatic eruption, a Surtsian eruption that occurred on July 3rd. Taal had a Surtsian eruption that occurred. Taal is a supervolcano. It is a caldera. In fact, it is one of the largest calderas in the world. It's not the largest, but it's among the world's largest, and it's also one of the newest calderas. Let's look here. I'm going to show you the Taal caldera. Already, you can see it right here. If you zoom in, you can see the Taal caldera right here. That is another larger caldera that is just southeast of Manila, but that volcano, they say, is maybe extinct. So you see there is a series of volcanic craters, large ones too, especially just southeast of Manila. This is because of two colliding trenches, two colliding subduction zones, one to the east and one to the west. There's actually two subductions. There's two trenches on opposite side of the Philippines, which is causing an unusually high amount of magma to be intruded, because you have two areas of subduction, which means you'll have two areas of volcanoes. You'll have volcanoes related to one area of subduction here, and you have another area of subduction driven volcanism on the west coast of the Philippines from the trench here. So let's go back to the 5Volks website, and see right here you have the East Luzon Trough and you have the Manila Trench. So these volcanoes is because of the Philippine Trench. Mayon, Igira, Isarog. So Pinatubo is as a result of the Manila Trench. So the Manila Trench is what forms Taal, perhaps Banahaw, and Pinatubo. However, this volcanism here is driven by the Manila Trench. So, and then you have another, you have the Cotabato Trench, which possibly forms these two volcanoes. And basically the Philippines is crisscrossed by numerous subduction zones, and including a colliding one here. So there is actually, this is where you would have significant earthquake activity here and somewhere here. And here you have a strike slip fault. So yeah. Now let's go back. So anyway, you can see what is going on. Very extreme uplift. I mean emissions of sulfur. So they're saying there's about 17 earthquakes. So let's look to the update for yesterday. So 16 low frequency volcanic earthquakes. And how many earthquakes? 17 volcanic earthquakes. And 16 low frequency volcanic earthquakes. That's usually a harmonic, that's usually tremor. But so there was one volcanic tremor, one. But you see, in terms of seismic activity, things have quieted down. But what I'm concerned about is what's going to happen if emissions drop, sulfur emissions significantly drop, and then you have more earthquakes, more tremors. That means the volcano is pressurizing as the magma is feeding into the system, but there's a blockage. This does not mean there's a blockage. In fact, such a high emission of sulfur means that there's pretty much a free flowing source of magma, that the magma will easily find its way to the surface. And that was evidenced by those eruptions that you had the other day. So clearly there is magma very close to the surface, right below the water. However, there isn't much uplift, right? There is not much intrusion right now. There is magma intrusion, but from what I can tell, it's not significant at the moment. So let's go for July 4th. Oh, sorry, bulletin. Bulletin, yeah, I wanted to look at a bulletin. So the bulletin for July 4th, let's see, 14,000 tons a day, 30, so Taal recorded 31 low frequency volcanic earthquakes. No volcanic tremor though. Taal, okay, 31 low frequency volcanic earthquakes. And today, let's see. They said 31. Oh, great. Shouldn't have closed. I should have. Okay, so let's go back to what I was doing. Sorry. So 31. Okay, and let's look. Let's compare July 4th. July 4th, July 4th, July 4th, July 4th, July 4th. Okay, next. I want to look for July 3rd. I want to compare. Okay, this is what I want to look at. So let's compare all these three. So you had 48 volcanic earthquakes, including 2 volcanic tectonic earthquakes, VT earthquakes, 40 low-frequency volcanic earthquakes, and 6 volcanic tremor events having durations up to 4 minutes. Today, this is what happened, July 5th. Just right now. 17, including 45 minutes, but you had a 45-minute harmonic tremor. That is indicating that there is about a 45-minute supply of magma going into the edifice or movement of magma, which is probably why you had such a high sulfur. And by extension, they mean uplift. Oh, the Taal region, which means that there's magma filling into the Taal region. So it means that this is what I'm seeing. This is what I'm seeing. So there's deflation here. See? Updated July 2nd. Yeah, the eruption was pretty small, but they're considering it a big thing, I guess. Okay. Yeah, that's a ferratomagmatic eruption. This is not a ferratic eruption. This is a ferratomagmatic. The difference is ferratomagmatic is driven when you have water interacting with magma at the source. A ferratic eruption is steam driven. This is not steam driven. This is driven by magma interacting with water. Like this is a Surtsian eruption. Anyway, things are getting very scary at the volcano. So let's look at this. And the eruption happened on July 2nd. Let's see when they erupt. The eruption happened on July 2nd. So let's go to before the eruption happened. Let's go to July 1st is when it happened. Bulletin update. Let's see, what was that update for at 3:37 p.m.? Yep, ferratomagmatic plume with no accompanying volcanic earthquake. Okay, let's see. And that day, 8 a.m. Ooh, yes, that looks pretty. It's the increased unrest. We're getting 10 volcanic earthquakes, including 8 low-frequency volcanic earthquakes and 2 volcanic tremor events of durations of 40 to 110 seconds. So yeah, that's probably with the shallow area. That's more shallow. That's probably that, and this is what probably drove that eruption, right here. And low-level background tremor that has persisted since April 8th. Wow, months and months of low-level background tremor. That is a lot of That's a lot of magma intrusion. Holy crap! High levels of 2,000 meters. Oh wait, how much? 6,685. That's already really high. Addition, fog was observed over Taal Caldera. Volcanic smog. Volcanic fog. Yeah, sulfuric fog basically. Caldera basin volcano has begun deflating in April 2021, while the Taal region continues to undergo a very slow uplift since 2020. These patterns indicate overall that magmatic unrest continues to occur at shallow depths beneath the edifice. Yeah, basically. And now, earthquake information. Yeah, 112 kilometers. Nope. I need to look at something shallow. Batangas. Nothing for Batangas, basically. Batangas. Nope. Batangas. Let's see if that's related to the volcano. Nope, not at all. Not at all. Yeah, not related to the volcano at all. Let's see. 14s, anything in the 14s. Laguna. It's probably in the Laguna Caldera. Somewhere in that Laguna area, right near the Caldera. Could be. So it looks like it's Mount Makaling. I think this, yeah, so it's basically, this looks like one big, this whole area could be sharing one big magma chamber. I mean, there has to be a big underlying magma chamber because this looks like a volcanic complex. Taal, Laguna Caldera, and another volcano, Mount Makaling. See, it last erupted in the Holocene, which means in the last 10,000 years. So you have the Laguna volcanic field, right? There is a big possibility that this whole volcanic complex shares one large magma chamber. I mean, it could also be smaller magma chambers, like each could have their own. But since this is related to subduction, there are several possibilities. You have Banashao volcano here. You have Taal volcano here. You have Makaling here, and you have Laguna. So this whole region, this entire region here is very volcanically active. Something is telling me that you're having, and it's not like spread out, it's all clustered together, indicating that there is a large magma chamber, very large magma chamber, possibly feeding all of these volcanoes, possibly feeding all of them. But right now, it's mostly feeding Taal. Why? Because Taal has been historically erupting very often. And Taal is probably sucking all of the magma from these other volcanoes, which is why they are not erupting, because Taal is basically the main vent, while these volcanoes here are not. However, Mount Banasha still erupted 1908, so something is telling me that, look at this, Banalin Bay in the shape of a caldera almost, look at that. This whole area, it's caldera shaped. Caldera. I mean, it could be a series, this could be this whole area could just be one giant volcano. I mean, keep in mind that Lake Toba shares a magma chamber with Mount Sinabung. Not Sibatun, Sinabung. This volcano right here shares a chamber with Mount Sinabung. So Sinabung. So Mount Sinabung shares a magma chamber with this volcano. It was determined that they did an ash composition and it shares a magma chamber. Sinabung does share a magma chamber with Lake Toba, despite this huge difference in distance. Look at this. So why? So let's go to about 10 kilometers. So why can't, if Sinabung is all the way here and shares a magma chamber with a volcano here, why can't this whole area be sharing one magma chamber? I mean, it's definitely possible that all these volcanoes in this region, from south of Manila to potentially Batangas, shares one magma chamber. So from Lucaban to Nasagabu to Manila to Batangas could be sharing what could be a magma chamber underlying all of these volcanoes. One large magma chamber, I would say 30, 40 kilometers down. And then you have individual magma chambers at a shallower depth. I mean, this is just a theory of mine, but I could be wrong. It could also be that it's just individual volcanoes with separate magma chambers, but Campi Flegrei and Vesuvius share a magma chamber, and why can't this whole region share one large magma chamber? It definitely makes sense, and I believe that they do, and maybe they do. I think Laguna Lake does share. Does Mount Luna does Mount share a no. They're very small? Okay, you're calling Taal small. This is the entire volcano. This is not the volcano. Lake Taal, let's go to satellite. My friend, this is not the volcano. This is just the main crater. This whole lake is the volcano. This whole area is one big caldera. You see, this is the caldera. This is the Taal caldera right here. I'm going to draw the outline right here. You see how you have a sudden decrease in topography? I should be looking on a topographical map, and I will show you the outline of the Taal caldera. It's massive. It is a massive caldera. It's not just a lake, it's the surrounding area too. Remember how you were having cracks all the way here, down here cracks? This whole area is the caldera, guys. This is one large caldera. It's incredible, but yes, this entire region is one large caldera, or several overlapping calderas. But this is a caldera. This whole area is the Taal caldera. See, right here, from Tagate down to Lemery, down to Taal. So, and then it possibly extends. I don't know how much further, but so yeah. Now you want to see what the Taal caldera is? Let me show you the outline of the caldera here. Okay, this is looking at the topographical map. So Tagate right here. Okay, right here, the caldera, the outline of the caldera. Looks like there were several overlapping calderas. Laguna caldera. It's huge. Yeah, it's a giant caldera. Look at this. It's massive. Massive caldera here. Yeah, I mean, the Laguna caldera makes Taal look like nothing. But then let's look at Yellowstone. So this is the topographical map for Yellowstone. So this is Yellowstone Lake right here. Guess what? It's Yellowstone National Park. You see this whole area, the Snake River Plain? This is the trail of the caldera. This is the trail of the hotspot. You can see, you know, caldera, caldera, caldera. So this Snake River Plain is basically follows the Yellowstone hotspot, the trail of the calderas. See, but it's hard to outline the rim of the caldera because you'll have, you know, mountains here. But you can basically trace, if you look closely, now the caldera basically ends somewhere around here. So definitely a caldera here. You know, you're having West Yellowstone. It's pretty high up. Yeah, it's probably because of the resurgence. But it's very easy to find Long Valley. That is just, yeah, super easy to find. Coso. Okay, looks like I have to go up here. There's a Long Valley caldera here. Long Valley, so yeah, you can definitely see the outline of that caldera right here. And it's pretty evident with Taal and even Campi Flegrei. Napoli, so Naples. So now I'm coming in on Naples, right? There, caldera right here. You can almost outline the caldera here. You can almost draw the outline. The thing is, but then what is this? It's very irregularly shaped. But Pozzuoli is rising at a rate of 1 meter per, or basically a few centimeters a month. So let's go to Iwo Jima. You know, I don't know if you're familiar with Iwo Jima right here. So I'm going to look at where Iwo Jima is located. Iwo Jima. Iwo Jima is located, so this is a large volcano. There's Iwo Jima right here. Yep. Do you know that where these soldiers landed? So that's Mount Suribachi. You know what this is here? That is the Resurgent Dome, guys. That is the freaking Resurgent Dome. This is the entire volcano, guys. This is the entire volcano. This is the Resurgent Dome. And it's been uplifting at a rate of, this area is uplifting at a rate of 1 meter a year in some places. There's extreme amounts of uplift on this island. This could be the next place to have a supervolcanic eruption, possibly, or at least a caldera forming eruption. So yeah, this area, you know, where we landed, you know where the soldiers landed on the beachfront? This is all new. This is all new beachfront. They landed in this area here. This is like the old beachfront. See where they drew the line here? This used to be where they landed. And now it's 20, 30 meters, 16 meters above sea level. This is where they went. They didn't land here. No, they landed about 15 meters. So they landed like here. And yet, where Yotojima, yeah. Motoyama. Right here. Noted the overall pattern of deformation seen in the last several 100 years averaged to half a meter of uplift per year, but often exceeded uplift rates of 1 meter per year. They plotted the uplift of substances during the January 2006 to late January 2007, concluding that the formation pattern is very compatible, both that subsidence, which had continued from 2003, rapidly changed to uplift, and an increase of seismicity was also observed simultaneously. They divided the uplift during August 2006 and 2003. The authors used gravity and magnetic data to constrain the shape of the shallow intruding magma under the island's main edifice, Motoyama, also spelled Motoyama. The authors inserted in the Bullis northeast portion of the island. Remember where I was showing you Motoyama? Right here? Yeah. That is because of all the magma uplift. Huge amount of uplift, like over 100 feet. This is incredible. So yeah. 100 degrees Celsius, the same as observed January 2011. Associated discharges reached a maximum height of 20 meters above the crater. Okay. Caldera. Yep. So now let's look at Taal. Let's update this. See if anything has changed. Let's see. Come on, upload. Come on, change. So 2:20 p.m., which would be about 2 a.m. here. Looks like no change. For now, I'm going back to bed, guys. It's getting really, really late, and I gotta be going to sleep. I just wanted to let you know that Taal is going to be having a massive eruption. This is also this 22,000 ton of uplift is actually a record. This has never happened before. Oops. So 22,628 tons. That is actually an all-time record for Taal. Never has Taal ever emitted that much sulfur in its history. In fact, when I'm gonna look up Taal in the news, oh my god. Mud volcano? Are you kidding me? A mud volcano. Oh, jeez. Okay, a mud volcano. Jeez. Yeah? Another reason why you shouldn't be using fossil fuels. Yeah, then the Mexican fire. Yeah, look what happened today. Oh, come on. Stupid ad. Thank you for watching. I'm going to be going to bed now. Good night, everybody.